Hello, Namaste, and welcome to our new course, Introduction to Routing and Packet Forwarding. Since in this course we are discussing about the very basics, how the router works and how router forwards the packet. So before learning high level designs, we should be very familiar with the basics so that it will help you to troubleshoot the issues. So let's join to the course. In this course, we are going to study about how router is similar to the computer and what are the operating system does the router have, what is the hardware design, and what is the routing process. We will also learn about how to configure devices and apply IP addresses to the devices. We will look at the structure of routing table and also know about how router determines a path and switches packets. So if we talk router as a computer, then a computer that specializes in sending a packets over a data network. So we call a router as a something like a computer that are responsible for interconnecting networks by selecting best path for a packet to travel and forwarding a packets to their destination. So what router does is take the packets from a source to a destination. What could be the destination? The destination could be some IP addresses. It could be IPv4 or IPv6. Routers are generally have two connections. WAN connection, also known as a connection to the service provider, internet service provider, and another is a LAN connection. Data is sent in form of packets between the devices. So what the router does is it sends the data from one location to another. So data is sent in form of packets between two devices. So if this source wants to reach to this destination, then the router send packets between two devices. Okay, routers are used to direct packets to its destination. So if this is the source and if this is the destination, the router forwards the packets to its destination. Routers direct packets to their proper destination. Routers connects different media. Okay, for example, this is the Ethernet media and this is the serial link. Then the what router does is it connects to different media as well. Routers examine packets, destination IP address, and determine the best path by enlisting the aid of routing table. So how does the router forwards or examine the packets to its destination IP address is through a routing table. The routing table, if we run the command so IP route, then we can see what are the routing tables and does the router have. We can see here the IP address of 1.0, 2.0, and 3.0. Actually here all the networks are directly connected, so I think, yeah, all the networks here is shown as a directly connected networks. Okay, routers use the routing table like a map to discover the best path for a given address. Okay, so the router just use database information from a different networks and collects it, updates it, maintains it in the routing table. So if you look a router as a computer, then we can find the different components. It includes CPU, which executes operating system instruction. So it executes the instructions from the operating system is the function of the CPU. Similarly, the RAM, which is also known as the random access memory, contains the running copy of configuration file. Stores a routing table. A RAM contains a lost when power is off. So when we switch off the router and switch it back on, then whatever is stored in its running configuration, those may be lost if we don't save it. So the other one is the ROM, or which we call a read-only memory, holds diagnostic software used when a router is powered up. It stores the router's bootstrap program. So ROM holds a diagnostic software used when a router is powered up and stores the router's bootstrap program. NVRAM, which we call a non-volatile RAM, stores startup configuration. This may include IP addresses, routing protocol, host name of the router. Flash memory contains the operating system, Cisco IOS. Cisco IOS is mainly saved in flash memory. And there are various interfaces that are used to connect networks. Example of interface types are Ethernet, fast Ethernet, gigabit Ethernet, 10G, 20G, maybe 40, 100. and the serial interfaces and management interfaces. So these are some of the components of a router. If we further look here, then whatever have been discussed earlier, like there's some interfaces, slots, and there are ROM, flash, similarly user interface, console cable, and all these are connected to the central processing unit CPU with the CPU bus, and the system bus is used to connect to different slots using a system control ASIC. Okay. Mm, if you move further, then we can find that the major phases to the router boot up process include test router hardware, power on self test, execute bootstrap loader, locate and load Cisco IOS software. So it will first locate it, then it will load it. Locate and load startup configuration file and enter setup mode. Bootstrap programs looks for a configuration file. So bootstrap program always look for configuration file which is always saved in the flash. Okay. So it is similar to what we have discussed earlier. It has uh, perform post executable bootstrap loader, locate iOS, load iOS, locate configuration file, and execute the configuration file or enter the setup mode. How to verify the router boot up process, and the show version command is used to the information about the router during the boot up process. So if we run the command show version, then we will able to see a model number of a platform, the image name and iOS version, bootstrap version stored in ROM, image file name and where it was loaded from, number and type of interfaces, amount of NV RAM, amount of flash and configuration register. As you can see here, if you run the command show version, then we can see iOS version, which is ERC 2600 software. Similarly, a bootstrap version, we can see version 12.13 are similarly model of CPU, amount of RAM, number and type of interfaces, amount of NVRAM, and amount of flash. So router as a computer, router interface is a physical connector that enables a router to send or receive packets. Okay. Each interface connects to a separate network. So each interface connects to a separate network, consists of socket or jack found on outside of the router. Types of router interface: Ethernet, fast Ethernet, serial, DSL, ISDN, and cable. Each individual interface connects to a different network, thus interface has an IP address marked from that network. Okay. So LAN interface are used to connect router to a LAN network, has a layer 2 MAC address, can be assigned a layer 3 IP addresses. Okay, usually consist of RJ45 jack. WAN interfaces are used to connect routers to external networks that interconnect LANs. Depending on the WAN technology, a layer 2 address may be used. Uses the layer 3 IP address. Okay, WAN interface usually uses the layer 3 IP addresses. Routers and the network layer. Routers use the destination IP address to forward packets. So there is a destination IP, destination subnet, and the next hop addresses through which the router use the to forward the packets. Okay, where you want to reach destination IP. The path a packet takes is determined after router consoles information in the routing table. So it will check the information in the routing table, then it will forwards the packet where it wants to check. After router determines the base path, router is encapsulated into a frame. Sorry, packet is encapsulated into a frame. Frame is then placed on a network medium in form of bits. So what it does is it will go to the layer by layer. First it will packet into a frame, then frame into the bits. After finding the base path, where is the base path found? The base path is found in the routing table. Router receives a stream of encoded bits. Okay, here the router will receive the encoded bits. Bits are decoded and passed to layer 2, then it will pass into layer 2, and router de-encapsulates the frame. Okay, and then the network layer de-encapsulates the frame and remaining packet passed to layer 3. Okay, then it will pass to routing decision made at this layer by examining destination IP address. Packet is then re-encapsulated and set out of outbound interface. Then again this process continues till it reach into a destination network, and after that it will have its own other layers to examine their own protocols. Configure device and apply addresses. Implementing a basic addressing scheme. When designing a new network or mapping an existing network, you must provide the following information in the form of a document. So when you first design a new network, then you need to have a topology drawing that illustrates physical connectivity. Okay, as you can see here, this switch 1 and R1 can be connected throughout fast Ethernet 0/0. Address table that provides the following information: device name, what is the name of the device. Let's suppose this switch name is S1 and this router name is R1. Similarly, another router is R2 and the switch name is S2. Similarly, PC2 and PC1 are the device name given to our devices. Interfaces used. What are the interfaces used for the connectivity? Like fast Ethernet 0/0, serial 0/0 are the interfaces used for the connectivity. Similarly, IP addresses and default gateways also should be mentioned properly in a new network design. I hope this has been very informative to you. I look forwarding to provide a more information and knowledge about the routing processes. Uh, Thank you for watching. I hope this has been very informative to you.